Hello everyone. In this lecture we will discuss the property of real numbers and we will discuss also the intervals. So in the previous lecture we have discussed about the real numbers. What are the real numbers? What are the types of the real numbers? Like natural numbers, integer numbers, rational numbers, irrational numbers, imaginary numbers, complex numbers, like this. So, to, so we are going to discuss the property of real numbers, and the first property is closure property. So, what is the closure property? Let a and b be two real numbers, then their sum, that means a plus b, is a unique real number. This is called the closure property with respect to addition. That means if we take two real numbers a and b and we sum up them, we again get a real number. Second, suppose we take two number a and b and we multiply a and b. So this multiplication will be again a real number. This is called the closure property with respect to multiplication. Here is the example. So in this example, we have taken a equal to 5 and b equal to 7. So these are the two real numbers. So I want to add up these numbers a and b. So 5 plus 7 is 12, and you know that 12 is the real numbers. So this is the satisfying the closure property with respect to addition. With respect to addition means we are adding two real numbers, and that is again a real number. Same, if we multiply 5 and 7, we will get the 35. That means 35 is a real number. So this is again verifying the property of closure property of real numbers with respect to multiplication. Why we are saying the closure property with respect to multiplication? That because we are multiplying two real numbers. That means we are operating the property on two real numbers, and we are using the operation multiplication. So that's why we are called the closure property with respect to multiplication. Second property of real numbers is commutative property. If a and b are two real numbers, then if a plus b equal to b plus a, then we will say that commutative property hold with respect to addition. That means on changing the order of numbers, the addition will not be affected. Similarly, if a into b equal to b into a, if this property holds, then we say that commutative property hold with respect to multiplying. That means if we change the order of numbers, then multiplication will not be changed. So then we say that the multiplication property hold with respect to multiplication. So for example, we are taking here two numbers a and b. Here the value of a is 6 and value of b is 9. So suppose that I am taking a plus b, that means 6 plus 9, I will get 15. And second, I am changing the order. First I take the b plus a, and second is a, 6. So 9 plus 6. So 6 plus 9 and 9 plus 6. Both will give you the sum 15. That means this property a plus b equal to b plus a is verified. So we can say that the commutative property on these numbers verified, or the closure property hold on these real numbers. For the second commutative property with respect to multiplication, I have taken again the same number a equal to 6 and b equal to 9. So multiplication of 6 and 9 is 54, and I am changing the order of the numbers. First I will taking the b equal to 9, and after that 6. So 9 into 6, this is again 54. So here a into b equal to b into a. That means the closure property, sorry, that means the commutative property hold on the multiplication. third property of real number is associative property. Suppose that we take three real numbers A, B and C. So we here also have the associative property with respect to addition and associative property with respect to multiplication. So associative property with respect to addition, that means if we add two numbers A and B first, after that third number C, and if we add first last two number, that means B and C, after that third number C. So this sum from both sides will be same. So if the sum from both sides is same, then we say that the associative property hold with respect to addition. So similarly, this property, the property for the multiplication is, if we multiply two numbers, first two numbers A and B, after that the result will be multiply the third number C. If this whole result is same, if we multiply last two numbers B and C, after that first number A, if both sides result is same, then we say that the multiplication property, then we say that the associative property with respect to multiplication hold. To verify this property, here we are taking three numbers A equal to 2, B equal to 3 and C equal to 4. So first we are adding A and B, that means 2 and 3, and this sum is 5. So we are first adding A and B, and this sum is we are adding with respect to C, that means 4. So 5 plus 4 is 9. I am again adding the last two number, that means B and C, 3 and 4, 7, and this sum is we are adding with respect to A, that means 2. So this is again 9. So here A plus B plus C equal to A plus B plus C. So the associative property hold with respect to addition. Similarly, we are verifying the associative property with respect to multiplication. So here we are taking the multiplication of first two numbers A and B, that is 2 and 3. So multiplication of 2 and 3 is 6, and this result is 6 is multiply the third element, that is C, that is value is 4. So 6 into 4 is 24. So I am here similarly multiplying last two elements, that is B and C, that values are 3 and 4. So this multiplication will be 12, and this result is, when I multiply with respect to A, that means 2, I will get 24. So both sides, so value are same. That means I can say that the associative property with respect to multiplication hold. That means A into B into C equal to A into B into C, and here we see bracket. Fourth property is distributive property. Let A, B and C are three real numbers, then A into in bracket B plus C equal to A into B plus A into C. So here this, we say that multiplication is distributive over the addition. So to check this property, we are taking the three numbers A, B and C with values 2, 3 and 4 respectively. So here we will verify, we will check the both sides. So to check the left hand side, so first we take B, addition of B and C, that means 3 plus 4, that will be 7. When we multiply with respect to, that means 2, so 2 into 7 equal to 14. So left hand side is 14. Now I am verifying, I am checking the right hand side. That means I will check the value of A into B plus A into C. So A into B, that means 2 into 3 is 6, and 2 into A into C, that means 2 into 4, that is 8. So the addition of A into B plus A into C, that means 6 plus 8 equal to 14. So right hand side is also 14. So we can say that distributive property is verified. Next is identity. Let A be any real number, then A plus 0 equal to 0 plus a equal to 0. Then we say that 0 is the additive identity. So that means to find the additive identity, we have to search a number. On adding this number to any number, that number will not be changed. Suppose that if I add any number to 5, the value of 5 will not be changed. That means that number plus 5 equal to 5. So you can see that that number is only the 0 number. So 0 plus a equal to 0 plus a plus 0 equal to 0 plus a equal to a. So we can say that 0 is the additive identity. Or in other words, the sum will not be changed if we add 0 to any number. So 0 will be the additive identity. So as we have defined the additive identity, similar way we can define the multiplicative identity, like a into 1 equal to 1 into a equal to a. Here a is called the multiplicative identity. That means if we multiply any number with respect with 1, we will always get the same number a. Or we can say that with which number we should multiply any number a to get the same number. Your answer will be 1. So here 1 is called the multiplicative identity. So for example, we are taking, let a equal to 5 be any real number. Then 0 plus 5 plus equal to 5 plus 0 equal to 0 plus 5 equal to 5. So on adding 0 in 5 from right side or left side, we will always get the result 5. So here 0 is the additive identity of 5. Similarly, when we multiply 5 by 1 or 1 by 5, that means when we multiply 5 by 1 either from left side or right side, we will always get the 5. So here 1 is called the multiplicative identity of 5. Next is inverse. So how to find the inverse? Let a be any real number, then a plus minus a and equal to minus a plus a equal to 0. Here minus a is called the additive inverse of a. Similarly, a into 1 upon a equal to 1 upon a into a equal to 1. Here 1 upon a is called the multiplicative inverse of a. That means to find the additive inverse of a, we have to add a number to a to get the additive identity. That means we have to add a number into a to get the 0, because 0 is the additive identity. So suppose that I add b to a to get 0, then b is the additive inverse of a. So to get 0, we have to add minus a to a. So here minus a is called the additive inverse of a. Similarly, to get the multiplicative inverse of a, we have to multiply a with respect to with a number. The result will be 1. So we have to multiply a by 1 upon a. Either we are multiplying from left hand side or right hand side, your answer will be always 1. So when I multiply a with 1 upon a, I will get the 1. So here 1 upon a is called the multiplicative inverse of a. Here 1 is the multiplicative identity. So on multiplying a by the number b, we have to get the multiplicative identity 1. So we have to multiply a by 1 upon a to get the multiplicative identity. So here 1 upon a is the multiplicative inverse of a. Here we are taking the example, let a be the any real number. So to get 0, we have to add minus 7 to 7. So, or we can say that 7 plus minus 7 or minus 7 plus 7. This will always give you the result 0. So here minus 7 is the additive inverse of 7. Similarly, when I multiply 7 by 1 upon 7 from left side or right side, my answer will be 1. That is, I will get the multiplicative identity. So 1 upon 7 is the multiplicative inverse of 7. Next is definition of subtraction. Let a and b any two real numbers, then a minus b equal to a plus minus b. Let, for example, let a and b, here a equal to 8 and b equal to 2 be any two real number, then a minus b equal to 8 minus 2 equal to 8 plus minus 2 equal to minus 6. So how we have add these number we will discuss later. A definition of division is let a and b be two real numbers, then a division b equal to a into 1 upon b, where b should not be 0. Why b should not be 0? Suppose that b equal to 0, then this result will be infinite. Let a equal to 10, for example, and b equal to, let a equal to 10, b equal to 2, be two real number, then a divided by b equal to 10 divided by 2. That means 10 into 1 by 2, that will be 5. So division is nothing but subtraction. Here we have some notes. Note 1, to add two numbers with same sign. Suppose that we have to add two numbers with same sign. How will we we have to add their absolute values, and we have to use their common sign. Suppose that two numbers are with negative sign. Suppose that minus 10 and minus 15. So we add minus 10, 10 and 15, that will be 25, and we will use their common sign, that we will use the negative sign. So that means our result will be minus 25. Suppose that we have to add two numbers with a different sign, as in the definition of the subtraction. So subtract their absolute value, we will subtract the absolute values, and we will use the sign of numbers whose absolute value is larger, like 8 minus 2. So here we will subtract 8 from 2, we will get the 6, and we will use the sign of large value, that means we will use the sign of 8. So that means the result will be 6. To subtract two number, use the definition of subtraction to change the addition problem. So we will use the definition of subtraction as we have used in the last slide. So we will convert this problem into the addition problem. So that means 8 minus 2 means 8 plus minus 2. 8 plus minus 2. So that means this is the problem of addition, but his sign are different. That means addition with different sign. That means we subtract 8 from we subtract 2 from 8, and we will use the sign of large number. That means we will sign of. So this is the definition of subtraction. These notes are the sign of two numbers with respect to multiplication and division. Suppose that we multiply two numbers with positive sign. So the resultant sign, that means sign of multiplication, will be positive. Suppose that we multiply two numbers with one number plus with number with plus and second number with minus. So the result will be with negative sign. Suppose that we are multiplying two numbers and both numbers are with negative sign, then result will be with positive sign. So the result will be positive. Similarly, when we multiply minus and plus, we will get the minus. So the sign will be same as in multiplication as the sign in the division will be same as the multiplication. Suppose that we are using the division of two numbers and both numbers are with the positive sign, so the result will be positive with positive sign. If numbers are with one with negative sign, one with positive sign, so our result will be minus with negative sign. Suppose that we have to find the division and both numbers are with the negative sign, then our result will be positive. For example, I am taking minus 2. Sorry, for example, I am taking minus 10 upon 2 minus 2. So here my result will be 5, 2 divided by 10 divided by 2, and I will cancel out minus by minus, so the sign will be plus. So both sign are negative in division, then result will be positive. Our next topic is intervals. So intervals are the set of numbers that correspond to a line segment on the coordinate line. For example, if I am taking a is less than b, then open interval from a to b is denoted by interval from a to b with the small bracket. This is a line segment from a to b excluding the endpoint. That means endpoint will not be included in this interval, and all the points from a to b will be included. Similarly, closed interval from a to b denoted by closed square bracket a from a to b. So the closed interval from a to b is the line segment extending from a to b, also including endpoints. That means a and b. So this is denoted by the uh, geometrically. So the open interval from a to b takes all the points from a to b, but not includes the point a and b. So here it will contain all the points from a to b, but a and b will not be included. So this is the open interval. And closed interval from a to b, that means it will contain all the points from a to b. It will contain all the points from a to b, also a and b. These sets can be represented in set builder form, or these intervals can be represented in the set builder form. The open interval from a to b is the set that contains x such that x is greater than a and less than b. That means a and b will not be included in the open interval. Closed interval from a to b, this is the set that contains x, where x is such that x is greater than or equal to a and less than or equal to b. That means it contains all the points from a to b including a and b. So endpoints are included in the closed interval. An interval can include one endpoint and not other. That means it can include the point from one side and not from other side. Such intervals are called half open or sometimes half closed. Moreover, the table below shows that it is possible that for an interval to extend infinity in one side or both directions. That means from one side b can go up to the infinity. To indicate an interval extend infinity in the positive direction, b write plus infinity positive, read as positive infinity in place of right endpoint. And to indicate that an interval extend indefinitely in the negative direction, b write minus infinity, read as minus negative infinity in place of left endpoint. The intervals that extend between two real numbers are called finite interval, while the interval that extend indefinitely either in one or both directions are called the infinite intervals. Here are some intervals and their set notation, their geometrical picture, and their classification. For example, this is the open interval from a to b. So set notation is the set contains x, where x is greater than a and less than b, and geometrical picture is the set of points on real line between a and b, but endpoints are not included. Its classification is it's finite because endpoints are finite, and it's the open interval because it does not include the endpoint. Similarly, second example is closed interval from a to b, as you can see by the notation. It's a set notation is it contains the x such that x lies between from a and b, also including the a and b. So its geometrical picture is the set of points on real line, all the points from a to b including a and b. So this is again a finite set or finite interval, and it is also closed because it contains the endpoint and the endpoints are finite. So it's finite and as well as closed. This is the semi-open or semi-closed. It's closed from left side and open from right side. Why it's closed from uh, left side? Because it's includes the endpoint from the left side and it does not include endpoint of the left side. So this is the finite because endpoint are finite and it's a half open, or we can say it's a half closed. Similarly, this is open from left side and closed from right side. That means it will not include the left endpoint. It will include the right endpoint. So this is, both points are finite, so it's finite and it's half open, or we can say half closed. This is minus infinity to b. That means it will end all the point on the left hand side from the b also b. So it's infinite because one limit is one endpoint is infinite, and it's a close because it's including the endpoint. Second is minus infinity to b. Here b is not included. That means it's infinite and open. A to b, a to infinity. That means it's taking all the values from a to infinity, and that means from a to all the value in the positive direction as well as a. So it's infinite and closed. Second is open a to infinity. That means a is not included and it will include all the point on the right side from the a. So it's a infinite because one endpoint is infinite and it's a open. Last, minus infinity to infinity. Its set notation is r. That means all the real numbers. Geometrical picturization is all the real line, and it's infinite. It's open as well as closed. Here is some exercise. Define closure property of real number. Verify the commutative property for the addition for a equal to 55 and b equal to 27. That means you have to show that a plus b equal to b plus a. Similarly, you have to verify the multiplicative property for these numbers. Fourth problem is pick out the open interval from the following. So you have to pick out the open interval from these intervals. Fifth questions, you have to pick out the closed interval from the following. And sixth is you have to pick out the semi-closed. That means semi-open, half closed or half open in the following intervals. These are the some references from which we have taken the contents of this lectures. Thank you everyone.